Hello community, my name is Jordan Wong and this is my CS10 final project. And basically for my final project I wanted to simulate the properties of our group project, which is basically making a navigation circle. And if you click anywhere on that circle, you have a given velocity vector and a direction. And I wanted to simulate that on Snap with Sprite. And using these basic different orientations of the Finch, I created some sort of spaceship game, which is pretty cool. And that contains basically what our group project embodies, kind of teaching like physics in a sense to younger children. And my game is basically individual representation of that on Snap. So basically this is my project. So you can see the code here, and yeah, as I said before, using different orientations of the Finch, I can move. And so I can change direction like that. I could accelerate by putting the beak up. I could turn. And basically the point of the game is you want to get to that destination before the enemies get to you, or without avoiding, without touching any obstacles, which are these things that spawn randomly on the map. And so I won there. Say I lose and get touched, then it should play some like sad music. And out in space, these like concepts of acceleration, position, and velocity are kind of like they're pretty out there. So I think in space it would be a good place to do this type of stuff. Yeah, so basically that's my game. And my AI algorithm, basically I made an AI that for most of the time it should work, sometimes it doesn't work. It sends out a beacon to destination and it evaluates whether that path, using my function clear path, is clear. So if there's an interruption, say like an obstacle there, then the path is not clear and it wouldn't go in that direction. However, there's another function called reachable, and even if like the enemies are super close to the destination like this, and I'm not, he would choose to go to an edge either than go to the destination. And so in this case he would probably go to the left edge, try to go there, and then try to go to the destination from there, from moving from one edge to the other. Yeah, so this is my algorithm over here, and it just shows the different edges. So basically, if it can't get to the destination immediately, it's going to go to an edge, try to bait the enemies there, and then it's going to go traverse the edge to the other side, which you also can do if you're playing with the Finch, and try to reach the destination from there. But usually the runtime is kind of weird, so it does 2 cycles before it actually decides to move toward the destination after switching sides. And so let's see if I can get it. So this would be one of the situations where he would have to go to one of the edges. So he decides to go to the top edge. So sprites are moving. So if I bring the sprites close enough, make it go quicker. If the sprites reach this, enemy sprites reach a certain radius around my sprite, it's gonna move. Go across to the next edge. It's gonna evaluate whether to move, and he decides to juke again, which is the runtime error I encountered in creating the AI. He's gonna juke across the other edge, and he's gonna go back and turn back around, which is really weird. And he's gonna try to juke again. He goes to juke, and he goes for the goal. So that's basically how my AI algorithm works. It's not perfect, the runtime is bad, but it works for the most part. Sometimes he just ends up going from one edge to the other without making any progress at all. Sometimes he actually gets caught where losing conditions where he's surrounded on all sides, or yeah, that's basically my AI algorithm. And so with this game, I hope with our group project's choice of educating young children about, well, in my opinion, physics, and I take great passion in physics, I created this project to simulate that on Snap, and that's basically my group project. Yeah, all right, thank you.